Hi, we are Team G7, and this is our final tech presentation. This is Brandon Larned, a popular Overwatch streamer who joined the Overwatch League team Dallas Fuel in 2018. His popularity brought a lot of viewership to the team games, with peaks of up to 118,000 concurrent viewers, and consequently an increase in the sales of team merchandise. However, after just a year playing, Brandon retired due to physical and mental health issues. According to him, insufficient player management and relentless non-stop training schedule caused him problems like severe sleep apnea and burnout. These issues caused Brandon to retire early from Overwatch, and shortly after his retirement, several other players expressed similar concerns and decided to quit their competitive playing due to health issues. From interviewing members of the esports community, we learned the following 3 points. First, there is limited research on the physical and mental impact of esports on players, and most solutions focus on the in-game aspect of players. Secondly, there are no standard metrics to represent or study the physical and mental condition of players. Interestingly, the pro team representatives emphasize the need of these. And third, all data suggests these 2 points are most likely responsible for the overpracticing, injuries, and burnout that are recurrent in esports. Therefore, our solution then was to come up with an analytics platform for esports that not only tracks in-game stats, but also provides physical condition metrics to give players and coaches a better picture of the state of their players. Now we will show our UI prototype for our product.
So this is our UI prototype for our solution GamerTech. And over here you can see that for our solution we have 2 different users, a player and a coach. And for each user they would be seeing different things. So for the coach, they will be able to see a real-time view of all their players on their team. As you can see here, James is level 20, Alex is level 26, George is level 19, etc. And for each player, the coach can click into the player and see their account as a whole. And over here they can see the username, the levels, and they can also start the sessions, look at the data analysis, and also look at their insights for each player. Now in the top right corner you'll be able to see alerts, and we'll go more into depth about that later on. Going back to the sign up page, if the user was a player instead of a coach, they'll click on the player button and they'll see this screen. And once there, they can add a profile picture, they can have a username, password, and email, and they can also link their other game accounts to our software as well. And after they've signed up, this would be the screen that they would see when they open our application, which is a login page. And after logging in, they'll be able to choose different games that they want to view. And for our MVP, we chose OSU, so they'll be able to go into their OSU. And this is the game dashboard that they'll be able to see, which is very similar to what the coach can see. So for the data that we collected, the player can go into the data analysis section to be able to see the data that we collect. And over here, we collect the eye movement, the keyboard, mouse, and in-game data, which they'll be able to view. For the eye movement data, we plan on recording the screen as the user plays their game and overlaying a heat map of where they were looking at each second as they were playing the game. Moving on to the keyboard data, the user will be able to see the average keys pressed per minute during their gameplay, and also they'll be able to see which keys that they press for each minute. For the mouse data, the user will be able to see the mouse clicks per minute, as well as an overview of how many times they clicked for each 5 seconds during their gameplay as well. Finally, for the in-game data, the user will be able to see the current session in relation to the past 10 sessions that we've collected, as well as they'll also be able to see an overview of how well they did for the past 10 games. Now, moving on to the insights. When the user clicks on the Insight tab, they'll be able to see a chart detailing the performance levels for each game. And over here you can see there's an upper threshold and a lower threshold, which we set based on the player's average 10 games. And once they hit a lower threshold over here, there will be a notification that will notify the player that they've hit this lower threshold and that they should take a rest or do some exercise before starting the next session to improve their overall game performance.
As seen in the video, our product has 4 different data collection streams. Currently, we are tracking the accuracy score of the game, OSU, using computer vision technology. We use a depth sensing camera to track eye movement and capture the mouse and keyboard input of a user during their gaming session. Now, here's the data collection software that we made.
The first component is an eye tracking software that uses depth sensing cameras from Intel to track the location on screen where you're looking at. The eye tracking is bundled with a Python program that captures not only eye movement data but also keyboard data, mouse data, and in-game data to understand what a player is doing in the game. In particular, the in-game data gathering pertains to gathering the data of a player's gameplay to be able to rank their performance over time. In this game also, what we are gathering through computer vision is the accuracy of the player over time, which you can see in the top right corner pertains to how accurate the player is at clicking the tiles and following the game rhythm. The capture data is stored in CSV files that contain every type of data. For example, we have the data with the timestamp where it was captured and the X and Y coordinates where the person was looking on the screen, the keyboard data, the mouse click data, showing where on screen you were pressing and where a button was pressed or released, the mouse movement data, mouse scrolling data, and finally scores, which is obtained through computer vision that shows the percentage of the person playing the game, accuracy percentage over time.
In terms of our data analytics model, we have 3 stages to determine player statistics. For stage 1, we determine how some human-computer interaction metrics relate to short-term physical state, such as tiredness or cognitive fatigue. Then once we find those physical conditions, we will see how that is related to in-game performance in stage 2 by identifying short-term patterns in the data. Finally, in stage 3, we will predict long-term patterns in data and figure out if performance changes in the player is due to mental or physical conditions. Going back to stage 1, based on reports that we found, we know that it has already been explored by multiple researchers. Some reports we found used speech or even eye data to detect fatigue, which is very similar to what we hope to achieve with our solution. For our first model, we plan on creating an artificial neural network model that will be fed the data obtained by our capturing software. The data will be normalized and labeled with the player's performance, which will be explained soon, and then split in chunks of data of 5 seconds each. Each chunk contains process metrics that are averaged over the 5-second period and that will be inputted to the model. And they will be labeled using the label from the song the chunk belongs to. The number of hidden layers and nodes will be determined after experimentation using 80% of the data for training, 5% for hyperparameter validation, and 15% for testing. This was not possible due to COVID-19, however. Here are some of the metrics that we will be using. We will be focusing on keyboard, mouse, eye tracking or gaze, and head metrics, as stated in our final report. Keyboard focuses on the rate and frequency of pressing keys. Mouse metrics focus on the movement of the mouse and clicking frequency and rate. Gaze metrics focus on eye movement and speed. And finally, the head metric focuses on the position of the head relative to the computer monitor. The metrics listed in this slide come from various research articles, which identify correlations between physical condition and the given metric. For example, the metric of distance of the mouse to the straight line, which shows statistically significant differences for fatigued and rested individuals, is the sum of the distance of every point in the path of the mouse movement to the imaginary straight line between 2 consecutively clicked points. Other statistically significant metrics include key downtime, mouse velocity, and distance during clicks. As these metrics have been shown to have success predicting fatigue, we chose them in order to develop our initial model, which could then be built upon. The data gathered for one subject playing one song will be normalized in time such that the beginning of the song has a timestamp of 0, and the end of the song has a timestamp of 1. Then using the area under the curve of the accuracy of the player, the accuracy will be classified into 5 different levels of performance. For example, a game session where a player scored an area under the curve above 80% will be labeled with a performance level of 5, the highest score. Similarly, a player with an area under the curve of around 40% will be labeled with a performance level of 3. The second model does the same labeling and normalization of Model 1, but instead of averaging the process metrics of the 5-second chunks, it feeds the time series generated by the process metrics to an LSTM with the task of classifying the sequences into any of the 5 levels of performance mentioned before. Due to the outbreak of COVID-19, our team's ability to collect data from various users on our testing system was lost. Our testing system included a camera for eye tracking and a computer running the software to track the data. Unfortunately, we are not able to use data from a source such as OpenAI, as OpenAI has an emphasis on reinforcement learning, whereas we are conducting supervised learning, and additionally, OpenAI does not provide eye tracking data. Our proposed pathway for collecting more data in order to train our models is as follows. We will extend our architecture that we have already built to run the program on different computers. We will then administer the test to as many players as we can obtain. This will collect the preliminary data to help train the model. Once the COVID-19 outbreak has cleared up, we plan to collect more controlled data as we will be able to monitor the players and administer more extensive tests. With these more extensive tests, we will be able to collect data from teams for longer periods of time and observe the results when they play in competitive games. And finally, thank you for watching our presentation.